Intro Algebra Lesson 2-6A. Now that we have our concept down for multiplication of positive and negative numbers, we can introduce a very important property known as the distributive property. This is used countless times with solving, and there's more on page 11 or 100, but basically what it means is if you have a situation where there's some parentheses, and the number outside the parentheses is going to get multiplied by each of the numbers or variables or combinations of numbers and variables inside the parentheses. So what I mean by that is this. If you have two numbers that you can't actually add, because I don't know A and I don't know B, inside the parentheses, but the outside number is being multiplied, you can take the outside number and multiply it by each of them. So now you would have 4A and 4B. That's the distributive property, the number on the outside multiplied by each. It does work to reverse as well. If you can look at a problem and you can see that there are two values that they have in common, or something as a factor that would be in common, then you could use like a reverse distributive property and pull those out, what's in common, and leave what was not in common. So it does work both directions. Alright, another example of this would be if there was, even if it has subtraction, that's okay, the subtraction stays. You'd go 3 times r is 3r. You don't have to have like parts to multiply, so 3 times 2v, 3 times 2 is 6v. So that's an example of the distributive property. If the number on the outside is multiplied, you can do it by each number on the inside. And we can prove that this works. Let's say you had 4, and on the inside was 3 plus 2. Now I realize that everybody can go 3 plus 2 and get 5, and then 5 times 4 is 20. But let's see if it works with the distributive property. Let's see if it actually makes 20. 4 times 3, 12. 4 times 2, 8. Add them together, it makes 20. So I feel a little more confident saying, yes, that's actually how the distributive property works, because I know it works with regular numbers. Even though I probably wouldn't apply it to this situation because I can add 3 and 2. But you can't add these together, and you can't subtract those two. So you have to have a way of dealing with the parentheses to get rid of them. Be very careful. A lot of times the mistakes are people add. So they think that this becomes 7 and that becomes 6. It's not addition, it's multiplication. You will have to watch your signs, and you also want to be careful that you don't just do it to one of them and forget the other one. A very common mistake is people go, oh, 4 times 3 is 12, and then they just leave the 2. You have to distribute it to everything inside the parentheses. Alright? So if we were looking at the area of this problem, we know that area equals the length times the width, which means that area equals 10 times 6, which would be 60 units, whatever those units are, inches, miles, feet, whatever, squared. Pretty basic. Now, what if it was the same rectangle, but the change was a 7 and a 3? If you wanted to find the area of this, you would go 6 times 3, which equals 18, and you would go, that's 6 times 7, which equals 42. And if you put the two together, 42 and 18, you end up with 60 units squared, which is exactly the same as this rectangle, because the 7 plus the 3 would make the total distance of 10. So it's the distributive property because this 6 is being multiplied by that 3 and by that 7. It's the distributive property with shapes. Alright, so here's another situation. What's the area? Well, I'm going to take this 6 and I'm going to multiply it by 3. 6 times 3 is equal to 18 units squared. And I'm going to take this 6 and multiply it by x. Now, I don't know what x is. So the answer is 6 times x makes 6x units squared. Now, because I can't add those together, I can't say that's 24x. They're not like parts. My units are still going to be units squared, but I'm going to say that the area equals 6x plus 18 units squared. And you know what that would look like? That would be just like this. Because x plus 3 would represent this entire side. That's x plus 3. So I'm really doing the same thing, which is to distribute the number on the outside times each piece, 6x plus 18 units squared. Exactly the same answer whether I put this side together in parentheses and distribute, or if I find each of the rectangles and put them together for my final answer. Alright? Now, let's just do the distributive property. I can't actually add x and 1, so Let's multiply. I got to multiply by both. 3 times x makes 3x, and 3 times 1 makes 3. So 3x plus 3 is my final answer. Don't accidentally write 6x. These are not like parts. You can't go any further than that. Right? We're just going to do as many of these as we can. Now, this time you're distributing the x, because there's actually multiplication here. So you're multiplying here and here. It's on the outside of the parentheses. It doesn't matter which side. So if you do x times 2, you end up with 2 times x plus, keep your same sign, 5x times x. So this is 2x, and x times x makes x squared. These are not like parts. Yeah, but they both have x's. True. But this one doesn't have an exponent of 2, so they're not the same. Don't try to put them together and make 7x squared. It doesn't work that way. D times the 2 minus the d. Change it to plus negative and then distribute it. So now you have d times 2. We always want to put the variable second and the number first. So that's 2 times d. And then d times d is going to give us negative d squared. Alright? If you left it 2d minus d squared, that would be the exact same thing. No different. Multiply the number on the outside times each number on the inside. We have addition. So negative 6x plus. Now remember, a negative times a positive makes a negative. You've got to watch your signs. So you have negative 6x and negative 18. Multiply in this direction and this direction. Don't just do one of them. Negative 3 times t, we always put the variable second. And negative 3 times 2, a negative times a negative makes a negative. So you end up with negative 6. So is that going to make negative 9t, because negative plus negatives make more negatives? No, because this does not have a t, so it cannot be combined. Alright? Again, I would change this to plus the opposite, and then I would distribute the negative 1. So negative 1 times a positive 1, they're not the same sign, that's going to make negative 1. And a negative times a negative makes a positive, so that's really 1x. So you can leave it this way, or you could say negative 1 plus x. 1x and x are exactly the same, no different. A little harder, I would still change this to plus negative. Now in between here is multiplication, so don't think that that means minus 4x. That's a negative 4. So I have to take and multiply by both of those. So I'm going to have negative 4x times 2x plus negative 4x times negative 3. I've multiplied it by both of the parts, which means right here, negative 4 times this positive 2 is going to make negative 8, and x times x makes x squared. On the other side, a negative times a negative makes a positive, so 3 times 4 is 12, and there's only 1x. There's no x squared. I cannot put those together because that one's squared and that one's not. And our last example, this one's tricky as ever. I would change this to plus the opposite. Now here's the thing. You want the opposite of all of this. What usually happens is somebody goes, oh, plus positive. That's only part of it. You don't want just the opposite of the first number. You want the opposite of all of this. So take the sign and make it the opposite of both. And someone's going to say, but it's already negative. I don't need that negative. No, no. Think of this as the word opposite again. Opposite and negative are basically the same thing. So that's the symbol for opposite. So the opposite of negative 2x is positive 2x. The opposite of negative 4 is positive 4. And you can't put those together and call it 6x because they are not like parts. So the distributive property, the number on the outside or something on the outside, gets distributed to all the parts inside.